Welcome back. In this video, we will talk about proof of work, and at the end, I will show you the basic version of the hash demo. As you know that the blockchain rely heavily on the computational expensive hash algorithm with no centralized authority or entity in blockchain network. So proof of work or the consensus algorithm or the protocols are the only way to maintain the governance in the network. Basically, proof of work is a mechanism to slow down the addition of the block so that no one party can create the longest chain and hack the system. Also, before the block is added to the chain, miners need to solve the hash puzzle, and the complexity of that hash puzzle or setting the difficulty level is achieved by specifying a target for the hash. This means a hash that starts with a string of leading zeros. Just an example, for example, if I have this number here, which is 100,000 here, if I set this as a target level, so my hash, the hash I'm looking for, should be less than this target, which means it's going to have more leading zeros at the front as compared to this number. So this is the requirement. In order for the block to be added to the chain, it has to satisfy the requirement of the hash value. So for adding the block to the hash, the first thing is the miners or all the nodes on the network needs to find out the value of the hash which satisfy the target value. And that target value actually defines the difficulty of the puzzle. So the miners in general, they take the previous block hash, they combine it with the current block header, and they add it with a random value which we call nonce, number used once. In a Bitcoin, it's a 32-bit value. Our previous block hash and the current block header is not going to change. So if you run a hash on it anytime, is because of the deterministic nature of the hash, you're always going to get the same value. So in order to find out the required hash or the hash we are looking for, we need to change the value of our input. And the only way we can do it adding this nonce, which is going to keep changing and is going to keep increasing until we find a value of a particular input which gives us the desired hash we are looking for, which is starting with a certain number of zeros. So this is what we call as a very general explanation of the proof of work and solving the puzzle in the blockchain network, whether it's a Bitcoin or Ethereum or any other platform. So let's see how it works. I'm going to just show you a basic version of the hash demo, and this will give you an idea how the miners find a desired hash with the leading number of zeros required in the hash function. Okay, so let's take a look at the demo. In this demo, I have a very basic version of the Python code to generate some hashes of the data and find out if that hash satisfies the condition of the desired hash I'm looking for. So it's pretty small code. As you can see, it's only 20 lines, right? And if you look at the beginning of at the top of the code, I'm just importing some libraries. Then I have previous block hash value. For the current block, I'm just generating some random bytes, and also I'm using nonce, which is the number used once. I'm starting with 0, and it's going to keep increasing until my program find the hash I'm looking for. So I'm using some iteration because, as I said, it's going to be brute force. Like miners needs to do brute force. They have to use different values of the nonce combined with the previous block hash and the current block header value and find out the desired hash. So I'm just running it for it's a pretty big number, like 100,000 or maybe more than 1 million times, right? My program, I'm just using previous block hash, current block, and joined with a nonce, and I'm just feeding that value into my SHA-256 function, giving me the hash value, calculating the hash. In Bitcoin, actually Bitcoin use a double hash, means you run the hash function twice, but for the simplicity I'm just using a single hash function, right? But I can easily do that, like double hashing on this value. So once, let's say, it's created the hash value, so my program is going to find out, okay, I need to define a criteria, what hash I'm looking for. So I will use the different values, like how many leading zeros I need in my hash. I will start with the 1 0, then I'll go 2 and 3 and 4 and 5 and 6. And you will notice that as I keep increasing the number of leading zeros I am looking in my hash value and this desired hash value, you will see it's going to take a long time for the program to find it out. It's going to be pretty quick for program to calculate and find the hash which has a 1 or 2 or 3 leading zeros, or maybe 4. But as you see, as I keep increasing from 4 to 5 and 5 to 6, and it's going to be long time for my computers to find it out the solution. Also, one thing to note is note that when my program find the desired hash, I'm going to break and I'm going to quit the loop. But that doesn't mean that's the hash value I found is the only hash value which satisfies this condition. There may be many hash values. So let's continue. Let me run this program and you can see the output rate. Okay, so first I will do, like, I will just run my program for finding out the hash value with the only one leading zero. So let's run this program. So as you can see that the nonce 14 created this value starting with hash 0. Let's change it to 2 now. I need to find, so let's see. So as you can see, it's creating a finding of hash value with starting with 2 zeros and is 87. Let's keep going and change it to 3 and save it. Let me run again. So you see now as this number increasing, the nonce of value 890 find this hash rate. So let's keep increasing now 4, and let's run this program again. So as you can see now it's keep increasing. If I go for the 5, then I think it's going to take even longer. So as you can see now, my program is just running, and here you go. So you can see it's getting harder and harder for my computer to find out the desired hash. So let's say if I keep increase this number to 6, then it's going to take even longer way. So as you can see, when I was looking for my difficulty level was very low. I was just looking for the 1 0. Nonce value as a 14 was quickly able to find out the hash value. For 2 zeros it take a little bit longer. It goes up to the nonce value of 87, and for 3 it goes a little bit more higher in the values of the nonce, and then it keeps going. For the 4 zeros you can see it's bump up to 4703, and for the 5 zeros it goes up to even higher, and for now it's for the 6 zeros I'm just still waiting for my computer to find out the right solution or the desired hash I'm looking for. Here you go. So you can see this value is way more bigger than the value of nonce is way more higher than the previous one. So if you keep increasing these leading zeros requirement, the finding out the desired or the matching hash is going to become harder and harder. And this is what exactly the proof of work and the hashing in the Bitcoin, and this is what the difficulty level is. Right. One more thing I'm going to do now, this is not the only value of the nonce that created these the desired hash. There will be many numbers can come up with the. So let's say if I take my break statement out, and let's try this again for, let's say, just make it a little bit simpler. I'm going to make it for 3 zeros, and let's run the program again. So as you can see, there are many values, many solution exists, right? And that's why different miners can find different values, and whoever find the first will be getting the reward of finding the solution. But again, if I keep increasing the number of zeros, as you can see, it becoming harder and harder, and it's going to take longer. Let's say if I change it to 4 zeros now, so you can see now it's a little slower than as compared to 3. But you can still see there are many different solutions for the value of the hash rate. So let's stop here and change it to the 5 and keep going. Okay, so we got our first value, and then it's going to take a little longer because we increase in the difficulty rate. Here you go, there's the second, and as the program keep going, it's going to find many different values of the nonce ending up with the same hash value. So let's stop it here. I think you guys get an idea how the hash function or the difficulty level work in the Bitcoin. So this is with a very simple implementation or the explanation of how the difficulty and the mining works in the Bitcoin or blockchain network. This is how the miners find the solution to the cryptographic puzzles, finding out the hash with lower than the target value, means having like a certain number of leading zeros they are starting with. So as you can see, my program is running and finding out the different values, and this is the same way different miners can find a different solution, and whoever finds the solution first will get the reward of finding or mining the block. So I hope you enjoy the video, and keep watching and looking for coming videos I'm going to be posting in the near future. Thank you.